So this is tutorial number 2. Water at 20 degrees Celsius flows in a 30 centimeter wide rectangular channel at a depth of 10 centimeter and a flow rate of 80,000 centimeter cube per second. Estimate the Froude number and the Reynolds number for this situation. So we assume that the density of water is 1000 kilogram per meter cube. The dynamic viscosity is 0.001 kilogram per meter second and the flow rate is 0.08 meter cube per second. So we assume that the channel is 0.3 width and the water level is 0.1 meter. So and then to calculate the Froude number, this is the equation for the Froude number. So it is Fr equal to V over square root gy. So and then to get the value of V, the velocity here, so it is equal to Q divided by A. So and then the value of Q is 0.08, so we need to use the SI unit here. So and then the A is 0.3 times 0.1. So we could get the velocity is 2.67 meter per second. So we calculate the value of gy here. So and then we get it is around 0.99 meter per second. So we substitute in this equation. So we get the Froude number is 2.697. So because it is greater than 1, so we could say that the flow is supercritical. So and then to calculate the Reynolds number, so this is the equation for the Reynolds number, rho VR over mu, but the value of R here is the hydraulic radius. So and then we need to calculate the hydraulic radius. So I think you already know. So if we calculate it, so it is equal to 0.06 meter. So and then we substitute into the equation. So we found that the value is 160,200. So because it is more than 500, so it is we could assume that the flow nature is a turbulent. Okay, this is tutorial number 3. An earthquake near the Kenai Peninsula, Alaska, creates a single tidal wave called tsunami that propagates southward across the Pacific Ocean. If the average ocean depth is 4 km and seawater density is 1025 kg per meter cube, estimate the time of arrival to this tsunami in Hilo, Hawaii. Okay, so means this is quite a big application for the Froude number and also for the Froude number and the hydraulic jump. So because when the water rise immediately, so the tsunami can occur. Okay, let's say from the Kenai to Hilo, it is around 4,480 kilometers. The density of water is given here as 1025 kilogram per meter cube. So and then again, we already know that critical condition, the Froude number is equal to 1, and we could assume that at surface of the tsunami, so means that is the critical condition. So means that in that condition, the Froude number is equal to 1. Okay. So and then we know that the equation of Froude number is V over square root gy. But the question here need to calculate the time. If we see this equation, we didn't found any terms of time. So means that we need to do a minor modification. So normally we change the terms of velocity here into the distance over time. So we have the distance over time divided by square root gy. So we have this one. And then we assume that because the hydraulic jump occur, so at the tsunami surface, So the Froude number is equal to 1, so we could proceed the calculation. So and then we rearrange the calculation. So we found that the time is equal to distance over square root gy. So the distance is 400. The distance is 4,480. So and then times 1,000 because it is 4,000 kilometers. So we need to times it 1,000 to make sure that the distance is in meter. We substitute the value of gravity here and we substitute the value of depth. So from the question, we assume that the average depth of the ocean is around 4 kilometers. So it means that it is 4,000 meters. So and then we could calculate the time the tsunami reached to Hawaii is 22,615 seconds. Okay, this is tutorial number 4. A rectangular channel is 2 meter wide and contains water 3 meter deep. If the slope is 0.85 degree and the lining is corrugated metal, estimate the discharge for uniform flow. So the question 1 to calculate the discharge mean the Q, and then if we have this situation we could calculate by using the Manning equation. So here the idea of corrugated metal here, so it is actually to show the roughness of the surface. So what you need to do is you need to see the table. So however, I will give these numbers in exam. Okay, so for the corrugated metal, it is equal to 0.022. So and then this is the equation, the Manning equation to calculate the flow rate. So and then what you need to understand is if the unit is SI unit, so it will become 1 over N here. So if the unit is British, you need to use 1.49 for this equation. So first we calculate the hydraulic radius, which is A over weighted parameter. So we have 3 times 6 according to the diagram here. So we have 3 times 6 and then we have 3 plus 2 plus 3 for the weighted parameter. So we get the hydraulic parameter is around 0.75 meters. So and then we could calculate the Q by substituting all the parameters inside the equation. And then we could get that the Q is equal to 27.422 meter cube per second. Okay, so this is tutorial number 5. The trapezoidal channel as shown below is made of brick wood and slope at 1 to 500 ratio. Determine the flow rate if the normal depth is 80 centimeters. So mean if the depth here is 80 centimeters. Determine the normal depth for which the flow rate will be 8 meter cube per second. So the question now is the depth is unknown, but the flow rate is given in the question. And the third one is let the surface be clean earth. So this is the resistance, or mean the friction of the surface, which erodes if V exceed 1.5 meter per second. So what is the minimum depth to avoid erosion? So in this question, it says that if the velocity more than 1.5 meter per second, okay, the erosion occur. So the erosion means the wear or it cause disturbance into the channel here. So mean we try to avoid the velocity to become more than 1.5 meters. So we need to calculate what is the maximum depth to avoid this situation. Okay, for number 1, so we know that the normal depth is 0.8 meter. The slope is 1 to 500 in ratio. So you know that 1.1 1 over 500, so it will become 1 500 like this, so it will become 0.002. So we change it into this term. So and then the value of n according to the table is 0.015, and then we could calculate the flow rate according to this equation. So and then I just gave a solution by using the equation of chord and cosec and so on. But I hope you could calculate this again by your own method. So the A here is the cross-sectional area. So means you need to calculate this area plus this area and also this area. So by using the angle given in this question, I think you already we could calculate all the parameters. So and then the weighted parameter, which is only this parameter, so also can be calculated because the value of y is given. It is 0.8 meter and the angle here is given. So you will get the area is 2.71 meter square and the weighted parameter is 5.2 meters. So the hydraulic radius will become 0.5212 meters. So and then we substitute into the equation, we could find that the Q is equal 5.23 meter cube per second. And question number 2. So we need to calculate what is the normal depth if the flow rate is given as 8 meter cube per second. So the idea is very simple. So we just substitute into the equation. So we know the value of a flow rate here, but we don't know the value of normal depth. So we use the equation here. So this is just equation on for these problems only. Please do not remember this equation if you solve another problem. So from this equation, so you could say that the value of y is unknown. So we need to calculate what is the value of y if the value of q here is equal to 8 meter cube per second. So it's very complicated. So you need to do by using trial and error. So if you have an Excel sheet, you could use Excel sheet, and then you will get that the y is equal to 0.993 meters. So about this equation, so I hope you could understand if we have this idea. So maybe the y here is unknown, so it's okay, and then you know this is the 2 meter. So mean the area of this one can be calculated as 2y. So and then you have this one. Okay, you already know the height is y, so means that you could calculate what is the value of this one because we already know the angle here. So the value here you will get in terms of y, and then might be you could get the area here, okay, by using 1 over 2a times b. So means time a here and b is here. So means that please try to create your own equation based on what you understand to find the cross-sectional area and also the weighted parameter. So this is quite a complex equation. So I hope you could do based on your understanding. So and then the third one. So if the surface is clean earth, so mean that the n is 0.022. So the maximum velocity is 1.5 meter per second. So this is the equation of the flow rate, and then we simplify it into the velocity. So we just neglect the value of a here, and then the q will become velocity. So and then we have this equation from the previous solution. So now what we need to do is we need to again to determine the value of y if the velocity here is 1.5. So after we use the idea of try and error methods here, we found that the y is equal 1.025 meter. So means that if the y is exceeding 1.025 meter, so the velocity will become larger than 1.48, so mean the erosion will start occur. So means that we need to make sure that the depth of that open channel must below than 1.025 meters.